And sometimes I accept the two answers. Okay. Why am I doing that? I don't want that. I want that. Alright guys, so let's have a look at this. So this is not about either chastising yourself or hunting for every single mark. I mark this test, you'll be said to know pretty leniently. Okay, so be careful of harassing me for marks because I'll harass back. And I'll say, oh, but I was a little bit generous here perhaps. Okay. So guys, you need to, but it takes a while, as I say, that takes a while to sink in. Okay. And sometimes you don't have time to practice like you want to practice. Okay, so that's just the way it is. Right, just move your road down, lift these, just move everything away at the same time. You're good. Okay. Alright.
That's a bit of a migration.
Yeah, but it's also good, okay, guys, you really want to have some tests in your school career that don't go well. Okay, because otherwise what happens at varsity, trust me now, you're going to fail quite a few tests at varsity. Okay, and what you're not needing to do is have a nervous breakdown and then say, oh, well, I'm doomed. You can fail tests and you can bounce back. I failed all my first two junior exams at varsity. I passed them all at the end of the year. Okay, I didn't leave my room for 6 months, but that's just the way it is. Okay, so, okay, this is not the time to get despondent, to feel sorry for yourself, blah, blah, blah. Okay, so, let's have a look. Okay, but there are some misconceptions. Okay, so if you're born and you've got 98% and you want to do something else, that's fine. Okay, you know who you are. Okay, you can do other stuff while I'm going over this. Okay. Right, this is a test. Right. So, let's have a look. Okay. A master brewer. Okay. First of all, how do you spell beer?
B-E-E-R.
B-E-E-R. It's quite good that you don't know how to spell it, Tamara. Okay. Tamara, we're talking about bears. The bear, the bear, that's right. Okay. There were no bears. Right. Okay. Colin and Bruce says the accuracy is whatever. Okay. So, we've got n is equal to 25, right? Okay. The sample mean was equal to 331,25 mils, right? And sigma for the population is 3,3 mils. I start a question by doing a little summary. X, Y is the sample mean. How do confidence intervals work? Okay. Based on your sample, get your formula sheets out. If you don't have a formula sheet, please hand them out at the back there. A lot of you don't know what's going on in their formula sheets. Okay. You need to be comfortable with that. If you haven't got one, put up your hand, Amelia will hand out to you. Right. Okay. Put your name on it now and start writing on it, and that becomes your little thing that every time you study, you remind yourself what each formula means. Okay. You're wasting your time. Okay. If you don't know what formula to use with. Okay. Right. Give me one as well, please. Sorry. Okay. Right. So. What is confidence intervals? How do confidence intervals work? You have to have an intuitive understanding of what things are about, otherwise you're just learning things off by heart. Okay. How do confidence intervals work? Somebody does a sample, based on that sample, they make a prediction with a certain degree of confidence of where the population mean lies. A lot of you don't know the difference between X bar and mu. They are different things. X bar is what? The sample mean, mu is the population mean, right? So based with confidence intervals, based on your sample mean, you get a confidence interval for what we think is happening with the actual population. Okay. So, what changes it? Okay, what do we want? We want a narrow width of the confidence interval, right? Narrow is better, because you want it to be between 20 and 1,000 tells you nothing. But between 20,01 and 20,02 tells you a lot. Okay. Right. So what happens if you increase n? Is that better or worse in your sample? It's better. Better is what? A narrow confidence interval. Okay, what does standard deviation do? Okay. It causes spread out the data. So it increases your width of your capish? Okay. Right. So, in this one here, that one a 94% confidence. A lot of you, I've been in this for years, a lot of you feel, diagrams, you need those. Okay. You need them. Right. So, doesn't take long. So you want a 94% confidence interval. Okay. What's on here? It's X bar. Why does that matter? Because if it's X bar, in this question, do they mention anything about things being normally distributed? No, because we're working with means, okay, and the central limit theorem says that means are always normally distributed. So that's X bar, that's Z, right? Okay. We know the actual mean is equal to 331,25. And this is where you guys are getting confused. For confidence intervals, the sample mean lives in the middle. Okay. This is X bar. Okay. For hypothesis testing and for normal distribution questions, mu lives in the middle. Okay, we'll get to that just now. Because you want to see how far things are away from you. or based on you making a score by probability. Kavish? Okay, right. So what is your objective? You want to know what's the lower boundary, okay, and what's the upper boundary. Kavish? Okay. So now, what do we do? Okay. Now this is where your formula sheet comes into play. Okay, which is the confidence interval formula sheet? You need to write on this now, write your name on this formula sheet, okay, and make sure you know where it is. Where is it? It's taken from the bottom at the left, right? Okay. That is your formula. And what should have you added there? You should have added mu is an element of. Okay. X bar plus, I will be much stricter on notation in your exam. So if you tell me mu is equal to, I'm going to say little mark. Okay. We don't know what mu is equal to. We know an interval that mu, with a certain degree of confidence that mu lies in. Away. Laptop away. Okay, away. Okay, right. So mu is an element of x bar, okay, plus minus z sigma over root n. It makes no difference whether, because it's normal distribution, whether it's a round or closed bracket. Kavish? Okay. So now what? Okay. We get mu is an element of x bar is equal to, okay, 331, stop me if I make a deliberate error, okay, 25 plus minus, okay, but we need to find z, okay, well, again, notation, okay, so z, you just tell me z is equal to z of what, okay, so you can talk about the critical z value if you want to, you can talk about it, but label something on here if you need to, right? So I would just say something like this. Okay, for 94% confidence interval, what's this area over here then? 0,47, right? Okay, so if the area is equal to 0,47, so if h of a, we call our z score a, we don't have to, okay, is equal to 0,47, okay, what's a equal to? So you look up an area of 0,47, and what do you get? What did you get? 1,4, what? 1,88. Do we all agree with that? Okay, so A or Z, I don't mind if you call that Z. Okay, but mention that this has got to do with the confidence interval, right? Okay, so if you put Z, that's fine. Okay, so Z or A is equal to plus minus 1,88, you said, right? Okay, again, okay, what does that mean? Okay, that the Z score for the lower boundary must be negative 1,88, and the Z score for the upper boundary must be positive 1,88. Are we happy with that? Okay. So we're going to have mu is equal to that, x bar plus minus 1,88. Sigma was what? 3,3. One person wrote 33. Careful of that. Root n is root 25. Stick that into your calculator. What was the final answer, Humera? Cool. Did you get it right?
Yes. Okay. Is 332,49.
332,49 is the lower boundary.
Oh no, that's the upper boundary.
Guys, you've got to do it in order, eh? Okay, so the lower boundary has to be on the left. Okay. Did I penalize you for that? Or didn't you do that?
I did write it correctly.
Okay, and the other one is?
330,0.
Okay. Right. So, they're 94% confidence that the mean lies between that and that. Kavish? Okay. If you went wrong, do you understand where you went wrong? Do you understand what a confidence interval question is about? You must, in your head, okay, have something, okay, that's incredibly rude. Okay, you need to be working through this. Okay. Right. So, you need to understand it. You don't have to, because you're done. Right. Okay, in fact, you can go do something else if you want to. I'm going to try something. No, wait, actually stay. Okay, stay. You can do something else in the class, but I need to figure out how I'm going to do this. Okay, right.
I really need it.
Yes, all right. Okay, right. Okay. Are you with me on that, guys? Okay. So now you get some kind of subjective question. You have to answer in context of real life. You can't just be a little robot. Okay. I know that it's a 94% confidence interval, right? Okay. And I know that the confidence for 94%, their confidence, in a way, that's probably in some ways the most accurate answer. But you all have to give some kind of advice, really. That's what it boils down to. What's going on in this question, in my opinion? And I was pretty lenient about this. Okay? So what's going on is what's being advertised? That the volume of beer is 330 mils. Personally, if I was inspector, I'd say, well, you're not ripping off the customer, so that's fine with me. You with me? So mention something like that. So you could say it's fine because it's over. You should mention it's a little bit over perhaps somewhere. Hey, because they're advertising 330. So the only disadvantage would be perhaps they're wasting a bit of money by giving a little extra droplet of beer. But they're not ripping off anybody else. Capish? Okay. If you said, okay, so I'm fairly lenient in that, but you have to mention some kind of subjective thing about that problem. Is it fine? Is it not fine? Okay. If you said it's not fine, it's too much, I'd also accept that. If you said it's fine because they're giving them too much, that's fine. Okay. But you can't just repeat the question. Okay. Right. So, the next one, very common question. Explain the effect on the width of the confidence interval. What is better? Okay. Do you want a confidence interval like that, or do you want one like that? You want it to be narrow. Does that make sense, guys? Okay. Why you want it to be narrow? Okay, so narrower confidence, that's your width of your confidence interval between the lower boundary. So here, this is your width. Okay. And you'd like that to be as narrow as possible and the confidence interval to be as high as possible. Okay. Those are the two good things you want. High confidence interval. Okay. High, narrow width, really. Narrow width is better. Okay. Capish? Okay. So, explain the effect of if the sample size is increased. If it's increased, the width decreases. Or becomes narrow or something like that. We good? Okay. Even I'm struggling why you don't want to do corrections. Is it just me? But surely this is an opportunity to figure out where things went wrong. Okay. Anyway, it's up to you. Right. Okay. Right. Next question. Okay. Okay. A lot of you, I think, were helped by the next part. Okay. Right. Okay. And that's fine. Do that. Okay. So the reading of the question, again, is quite hard sometimes. Okay. So you've got 80 people from a political party, ABC, who were asked whether, they were planning to vote in the next election. So from those 80 people, people said they were planning to vote. Okay? You with me? What are we talking about here? Are we talking about means? No. Okay, we're talking about proportion, right? What proportion of people are doing things? Based on the sample and alpha percent confidence, they even said the word proportion. Okay. Population proportion of people ABC who were planning to vote for this party was 0.468, 0.682. Okay. So what does that mean? Okay. What was the final answer to this question? They were alpha percent confident that between about 47 and 68% of people, would vote, that people that support that party would vote. Capish? Okay. So, K is the number of people, right? Okay. So there's two ways you could have answered this question. You could have said, right, well I know, one thing you'd have to do is you'd have to actually get p hat. What does p hat stand for? Again, it's notation. What's p hat? This diagram. These diagrams, in my opinion, are really important, guys. Where does p hat live? What happens in the confidence interval question? Based on a sample, we get boundaries for the population, right? Sometimes it's based on the sample mean, we get boundaries for the mean of the population, right? Okay, here, based on the sample, which is p hat, we get a lower boundary for p and an upper boundary for p, which is a population proportion. Okay, makes sense. Okay, so what have they told us at the moment? Okay, they've told us that this over here is 0.468 and this over here is 0.682. So how can I find p hat? It's those things added together divided by 2. Do you agree? Okay. So p hat is equal to 0.468, we'll have a break it now, plus 0.682 divided by 2. Okay? Amelia, what did that give you?
0.575.
0.575, right? So that's equal to p hat. So that lives over here. Are we good? Okay, so now I know that what does p hat stand for, guys? The sample proportion. How do I work out a sample proportion? Take whatever I'm looking at, which in this case is the number of people that vote, divided by everyone in the survey, right? Okay. So if I go back to this question, okay, P hat, we know is equal to the number of people, how many people voted? Did they tell us? K people voted, right? Okay, so P hat is equal to K over K. How many people were in the survey?
80.
80. Do you agree? So K is equal to P hat times 80. So K is equal to what? 0,575 times 80, which gives us 46. Are we good with that, guys? Does it make sense? Okay. And don't beat yourself up if you've got these things wrong. Okay. It takes a while for stats to sink in. Okay. Are we good? But for me, what's important is understanding these diagrams. Say to yourself, where does P hat live for confidence intervals? In the middle. Based on your sample, you get boundaries. Okay, like the previous question, X bar lives in the middle. Based on your sample, you get estimates of the boundaries for a certain degree of confidence. Capish? Okay, right. Now it says if K is equal to 46, determine the value of alpha to the nearest percentage, right? So what is alpha? Alpha is my confidence interval, right? Capish? Okay. What's the formula I'm going to be using here? Go to your formula sheet. What's missing from that formula sheet? What do we have to change in that formula? Okay. We've got to change it to P is an element of what? Okay. So that again, guys, should be on your formula sheet. P is an element of. Edit it now. P hat. Read it out for me, please, Donegal. P hat.
P hat plus or minus Z root P times 1 minus P over N.
Oh, is N under the root? I can't remember.
Yeah, it is.
It is under the root?
Yes.
The whole thing's under the root?
Yes.
Like that?
Yes.
Okay, thanks. Right.
Oh, so, oh yeah.
Is that right?
Yeah, yeah.
Okay. So what are we doing? We're getting boundaries for what we think is going on in the population based on our survey. Capish? Okay. So, what's P hat? 0,575, right? Okay, plus minus. Okay. Now wait, pause. Okay. I'm going to try to find Z. Okay, what's my plan? Okay. Okay, I found Z for one boundary, right? One of the boundaries. So you can either use the lower boundary of P or you can use the upper boundary of P, right? Okay, because do you agree with me? If I get, so this here is P hat, that axis, this here is Z. Okay, stay with me. Okay, so I want to get the Z score that goes with one of these boundaries. Okay, I usually work with the positive boundary. Okay, okay, if I find that Z score, based on that Z score that goes with this boundary, I can find what? Okay, that area over there, right? And then how do I find the confidence interval? I times that by 2. Are we good? Okay, so I'm going to pick the upper boundary. You could have used the lower boundary. So what's the formula for the upper boundary? Is it the plus or the minus part of the Z? The plus part, right? Okay, so therefore, P is equal to, okay, here I can say P upper, so now it's equal to some interval. If I was using the lower, I'd use the minus, right? Notation. Okay, Dominic, the examiner, she goes nuts about notation. Okay, so P upper is equal to P hat plus Z P hat 1 minus P hat. You don't have to write the formula again. Over N. Does that make sense, guys? What am I going to do with that? I'm going to find this Z score. Why does that help me? If I get the Z score, I get that area. Okay, so if we go do that quickly, okay, I'm going to get P upper is equal to P hat is 0,575 plus Z, sorry, I know the upper boundary of P. What's the upper boundary of P? Upper boundary of P is 0,682. Do you agree? So the upper boundary of P is equal to P hat plus Z, which is what I'm looking to find. P hat 0,575, 1 minus 0,575, all over n, which was 80. Kabish. Right. Finish it off. Because you guys are going into a coma. Go. Okay, check it if you got it right, then you get to chill. If you got it wrong, finish it off. Oh, it's like someone's having me murdered, guys. No one's died. Right. Okay, Jared. I'll give you 1 minute. Have a chat. This is the question.
Why did you lie?
I didn't lie.
Why you did?
It's possible.
Yeah.
No. That's the whole. Ow, 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 ow.
I didn't punch you.
No, you could touch
I'm just
It's like that. What is the necklace?
Right, so if I was doing this, I'd go that. I wouldn't show you working. I'd go that minus that. Right? Then I'd square both sides, so I'd square whatever that is. Okay. I don't know. What did you end up with there? 1 comma? You guys concur? Okay. Z is equal to plus or minus, well in this case it's positive, 1,94, right? So that's that Z score over there.
Yes.
Are we good? Okay.
How did you do the squaring?
So I would go, so what's 0,62 minus 0,57, 0,682 minus 0,575. Okay, actually I wouldn't square anything. Okay, that's going to be equal to Z times that, right? So then I divide that whole thing by that whole speech, 0,575, sorry, 1 minus 0,575, are we good? Over 80, and that'll give me Z. Make sense? Okay. Right, so you get Z is equal to 1,94. Are we done? Question was find the confidence interval to the nearest percentage. Okay, so go to your table, look up 1,94. Okay, what did it give you? What? 4738. Okay, so alpha is going to be equal to 0,4738. But that's that area in blue over there, right? So to get the whole confidence interval, what I have to do to that? Times by 2, right? And if I times by that 2, what do I get? 0,9476, which is 94,76, but they said give it to the nearest percentage, or do they say 2 decimal places? To the nearest percentage. So alpha is going to be equal to 95%. Are we good? Okay. Right. Stand up for 1 minute. Stand. Beat the person up next to you. Get out your rage. Do what you need to do. Huh? Right, stand. Hey, there's no choice. Everyone stand. Go. Not optional. Go. Go, go, go. Right, stand. Stand. Okay, right, stand. Right, bring your arms around. Okay, hit the person next to you even better. Right. Okay. Right. Then give it this one and also see if you hit them better. Right. Okay. Right. Then you wake up your brain. Cross your second line. Yeah. So put your right hand on your left ear. Okay. And your left hand on your right knee. At the same time. And jump. Okay, right, sit up. Right, okay. So, guys, you have to draw pictures. Okay. So it says here we've got some random variable x. Okay. And it's normally distributed, right? The mean is twice the standard deviation. So do a little summary straight away. Mu is equal to 2 sigma, right? Now, it says draw a picture. It's a normal distribution question. So in a normal distribution question, what happens? Based on the standard deviation and based on the population mean, we make estimates about probability. Right? Okay. So mu lives where? Okay. Mu lives in the middle, right? Okay, so this is equal to mu, and mu is equal to 2 sigma. Okay, that's x, that's z. It's not x bar, right? So mu is equal to 2 sigma, right? Then they say the probability that x is bigger than 5,2 is 90%. Right. So if I do that, okay, where's 5,2? Wasn't it any of you, by the way? I had to give you walking outside. Right. Okay. So that's 5,2, right? What's 90%, guys? That area is 90%. Capish? If you start drawing things over here, immediately you're going to be wrong. Because the probability, what's to the right of that? 50. And to the left of that, 50, right? So if it's going to be 90, it has to be a big area. Can I have a nod of consent? Okay, right. So this area over here, guys, is 90%. That green area is 0,9, right? Okay. So this area over here must be what? What's this red area? 0,4, right? So if my area is 0,4, go look up an area of 0,4 and that's going to give you your z-score. Hey, and looking at the diagram, is that z-score going to be positive or negative? This was the biggest mistake. That z-score has to end up being negative. This is a z-score of 0. So to the left of 0 it must be negative. Right, go look up an area of 0,4. And what do we get? So if we look up 0,4, we're going to get negative 1,28. That's the closest one, right? Okay. So z is equal to negative 1,28. So this thing here is negative 1,28. That's your z-score. Those two things go together. Finish? Right. What is your normal distribution formula? Okay, over here in the middle, z is equal to x minus mu over sigma. I'm not working with means. Okay, there's no n. Okay, so I know. So with these ones, again, your notation should look like this. And even if you've got full marks, check your notation, right? The probability that x is bigger, this is how you should start the question, is equal to 0,9, right? Okay. Then I probably have that in there. Okay. So now I'm going to have z is equal to, this actually doesn't matter so much in this case. I'm going to have z is equal to x minus mu over sigma. Fish? Okay. So what can I say? Z was what? Negative 1,28. What's my x score? 5,2. Okay. Now I want one variable, right? So I'm going to stick, it's easier to use mu is equal to 2 sigma, right? Minus 2 sigma over sigma. Right, finish it off, tell me what sigma is, and they want it to 2 decimal places. Right, so I'm going to get negative 1,28 sigma plus 2 sigma is equal to 5,2. So you got 2 minus 1,28 divided by 5,2. And now what do you get? 7,22. They said 2 decimal places. Okay. Right, so that's 7,22. Okay. But we know that mu is equal to what? Okay. But mu is equal to 2 lots of sigma. So mu is equal to 2 times 7,22. And we get what? 14,44. Pictures help. Okay. It's not about chastising yourself and saying, oh, I shouldn't know. Okay, and try it. correct what you don't understand, where things live on these diagrams. Okay. Remember that? Okay. Right, then we get to this question over here. Right, so it says, from a survey done at a school, Kate found that 55% of students wore a watch on their left wrist, 35% wore a watch on their right wrist, and 10% did not wear a watch. From a random sample of 20, how many students can Kate expect not to be wearing a watch? Well, it's 10% of 20, which is 10% times 20, which is equal to 2. That's just a little Christmas present. Okay? Now it says, a random group of 200 students was taken. Using a suitable approximation, well, there's your big hint. Okay. Find the probability that more than 125 students wore a watch on their left wrist. Bolded in left. Okay. And unfortunately, some people didn't read that. Okay. Yes, frustrating, I know. Okay. So, in that thing over there, this is going to be a normal approximation to the binomial, right? What's n going to be equal to? 200. X is equal to, probability of x is equal to number on left wrist, right? So what's p then? P is equal to the probability that's on the left wrist is equal to what? 0.55. Okay. 55%, we're working with left wrist. The probability of being the left wrist was 0.55, right? Okay. So, those are our parameters for now. Capish? Okay. But, do we want to go work out 125 plus 126? No, so we're in an approximation of the binomial, the normal to the binomial. Right, so, first thing I have to do is justify, can I use it? It says that explicitly. What's my formula for that? I work out NP. So, NP is going to be 200 times 0.55. What does that give you guys? 110. Okay. Which is bigger than 5, right? And then I look at N. 1 minus P, which is going to be 200 times 0.35, which is 90. Okay, which is bigger than 5. So therefore, you can use normal approximation to the binomial. Are we good with that? Is it 90?
Sorry. Yeah.
0.45, sorry, 0.45, right. Okay, thank you. Are we good? Okay. Right, so now I can justify the using. What's my next step? Okay, I have to find mu and I have to find sigma. How does that help me? What on the formula sheet helps me? Okay, well if you go to E of x, that's for binomial language. Okay, E of x is equal to NP. Okay, make a note underneath that mu is equal to NP when I'm using binomial approximation, right? Okay, I mean normal approximation to the binomial. So I'm going to say, right, next step, mu is equal to NP, and we've worked that out already, it's 110. Okay, so I've got mu is equal to 110. Okay, then how do I find sigma? Well, there's a formula there for variance, right? So underneath, right, sigma is equal to the square root of NP1 minus P, right? Okay, so sigma is going to be equal to the square root of NP1 minus P, which is the square root of 110 times 0.45. Okay, and do not round this off. Leave it in third form. What did it give you in third form, somebody? 22, root 22 what?
3 root 22 over 2.
Okay, so leave it like that, guys. You can't round off here. 3 root 22 over 2. Okay, so now I've got, for the normal distribution, I've got mu is 110 and I've got sigma is that. Capish? Now I draw a picture. Now we go on to the normal distribution, normal picture, normal Z formula, right? So my picture is that, okay, we've got, okay, what goes in the middle with normal distribution questions? Mu lives in the middle, right? So mu is equal to 110. What are we looking for? The probability that x is in the binomial, we're looking for the probability that x is bigger than 125. But here, it matters in the binomial language, right? So, what's the problem? What's the problem is that x is 125. That's 0, right, in the normal distribution. So you have to treat 125 as a bar. 125 would live somewhere there. Okay, and there is the bar that goes around it. And do you want to include any of the 125 bar? No. Okay, so what's this boundary over here? It's 120. This is my correction when I go from binomial to normal, from discrete to continuous. And then I want this area over here. So it's when I change to normal, okay, I'm looking for the probability that x is greater than 125,5. Okay? Right, now it becomes a normal distribution question, right? Okay, which will be equal to the probability that z is greater than x minus mu, which was 110, over sigma, which is 3 root 22 over 2. Right, stick that into your calculator. Okay. What did you get? So 2 decimal places. We're nearly there. Z is greater than what? 2, 2,20. Right, so go to your table. So this Z score goes there is 2,20. Look up 2,20. And the table will give you what, guys? The table will give us this area over here in green. Right? And if you look up a Z score of 2,2, what does it give us?
0.48.
Okay, 0.48? 61. So our area is going to be 0.5 minus, that's going to be equal to 0.5 minus 0.4861. Which is equal to what? 0.013. Okay, and there's your answer. Are we good? Okay. Very kind of routine process, normal approximation to the binomial. What's the steps? Justification. Find mu. Okay. Find sigma. Use your formula sheet to help you. Okay. Then do your correction using a diagram. Then it's just a normal question. You fish? Okay. Right. Okay. Right. It's probably going to be our last question. Right. Then it says, okay, the number of hours beneath. Right. You want to stand for 1 second? Stand. Push the person next to you.
No. Just stand up. Stand up.
My leg is also
You got kicked by a brother.
gone. That's so
Right, sit, let's go. Right. Okay, so here guys, okay, and I do understand where somebody went wrong. Okay, this did come from a past final paper, so what can you do? If you didn't understand it, then right, okay, so yeah. Okay, so it says here, in the past, so the past is what? The average working hour a week was 49.5 hours, right? Now she wants to check, okay, Benicia wishes to check whether the average working hours have changed, right? So she wants to check if they've changed. Okay, so what's our existing belief here? Existing belief is always what mu is, guys. It's never got to do with x bar. It's about your population, right? So your existing belief is that the working week was 49.5 hours. Okay, old beliefs were, she figured something's not quite right. So one tail or two tail test. The two tail test, right? You've got to get that bit right, otherwise it's going to be, Okay, they're going to be pretty strict about that in finals. Okay. So, what else do I know? What parameters were we given? We were given sigma was equal to 4,8. Okay, and she did a survey, and from her survey, she worked out that x bar was equal to what? 48, eh? Okay, mean of 48 hours. And how many people weeks did she look at? She looked at 40. So those are our parameters. Okay? Okay. What happens with what lives where in hypothesis questions? What lives in the middle? What happens with hypothesis testing? Okay. What lives in the middle? Mu lives in the middle, right? And we want to see how far things are away from mu. So in the middle, because the middle is always going to be H0. Okay. We're working with means, okay, so we don't have to be told in that question that it's normally distributed. Okay? And we've got mu, which is H0. The existing belief of mu was mu lives over there with a z-score of 0. You've got to understand that, right? Then they say they want us to test at a 7% level of significance. So if it's a two-tailed test, what's this area equal to here? 3,5%, right? Which means that this area is what? 46,5%, right? Okay. Which is 0,465. So what are my steps in hypothesis testing? I've got to first go find the critical value, right? Okay. So this I'm going to refer to as Z critical. Because if it goes beyond that, okay, there's a problem with the existing belief. So that is your critical region. Yeah. Yeah. So, okay, I look up, and so I would make a note here. Tell the marker what you're working with. Okay, alpha is equal to 7%. So therefore, Z critical is equal to what? So what do you look up on your table? You look up 0,465, right? That's an area. What Z-score goes with 0,465? 0,465, the closest thing is 0,4649, right? 1,81. Okay. So Z critical is 1,81. Pull that in here. That's 1,81. That is negative 1,81. Now what do we do? What happens in hypothesis testing? Now we do a test score on our sample. Okay. And if the test score ends up in either of those yellow regions, there's a problem with the existing belief. Capish? Okay, language. It focuses your brain using the correct language, right? It's not just a Z-score, it's a critical Z-score. Now what are we working on? Okay, now we're working on the test score. What's the test score based on? The test score is based on our sample, right? Go to your formula sheet. Which is the formula for hypothesis testing? Okay. It's this one over here in the middle, right? Then it's equal to x minus mu over sigma, right? Okay. So what's x bar? Okay, so Z is equal to x bar minus mu sigma over root n. Okay. So we're going to get the test score is equal to x bar was what? Okay. 48. X bar doesn't live anywhere here. Okay. So it's going to be equal to 48 minus mu, and what is mu? 49,5. Sigma is 4,8 over root n, which is root 40. Right, let's just finish this question. Okay, what do we get? Negative 1,198. Now we go see the results of the test. Where is the Z-score of negative 1,98? Okay, it's over here, right? There is your test score. Has it ended up in the significant region? Yes, it has, right? So 2 marks for finishing it off. Okay, so therefore there is sufficient evidence to reject H0. What does it mean in this case? Okay, working hours have changed. Don't know why she's complaining though. She's working less. Oh, so hour shut up. Right, working hours have changed. Okay. 1 mark for the standard sentence. Okay. 1 mark for something to do with the context of the question. Please bring your test back for the next lesson. I want to finish this off. I know it's boring, but you guys have got to get this right now. Okay. And I'm going to have an afternoon where people want to come rewrite. Okay. Not for marks. Okay. So that I can tell your parents. Don't worry when I send the email. She didn't really bother to rewrite. and in a rewrite she got so and so. So don't stress. Right, okay. Bye guys. Assemble now.
Oh, yes, so I forgot to ask you, can I use the corporate CV as a reference?
Yes. Can I mention your donut eating?
Oh, please don't.
Okay.
On